And what is up, everybody? We are in live stream number 100. That is correct, not 99, not 98. We are in live stream 100, the Data on Kubernetes community. Extremely excited to be here today to celebrate our 100th live stream. We all have some special things happening this week, some special announcements, some live music that we're going to be having given to us later this week. Maserati was not available to make it today for today's live stream, but we will be hearing from him later this week, as well as a couple of other surprises. So stay tuned for that. As usual, we will do a Twitter Spaces on Friday. So we'll be doing that, bringing in some of our members. We're going to have a little bit of an update, well, a little quick lightning talk about the history of data. So definitely check us out on Twitter if you want to find out more about that as it gets closer to Friday. But always looking forward to get new folks involved, hear some feedback, share stories, and of course, have a good time together. So we've done 100 live streams. You've probably seen on YouTube. And by the way, if you're not already subscribed on YouTube, hit that subscribe button right now. We always need more subscribers. But like I said, you can check out all the content that we've been making over the last year and 2 months. So just telling Sanjeev, it's been about a year, 2-3 months. And, you know, we've done a little bit of everything. We've had fireside chats. We've had deep technical dives. We've had hands-on labs. If you have any ideas about something that you would like to see in particular, some topic that you would like to know more about, as long as it relates to running data on Kubernetes, of course you can ask us, right? So feel free to reach out in Slack. You always have the Slack link readily available in the description of the video, so very easy to find. That being said, one of the things that we've learned since we've started the Data on Kubernetes community is that data is a very delicate thing, which is why when vendors go out to end users, going out to customers and are talking about, hey, maybe you should consider running your data on Kubernetes, sometimes there's a little bit of reluctance, you know, people are a little bit of hesitation. They say, well, what happens if I lose my data? And that's exactly where today's topic comes in. We're talking about backup and restore, which is why we are going to be in the very capable hands of Sanjeev, who's going to be telling us about Cape, an open source tool that makes backup and restore easier. But before we get into that, Sanjeev, welcome to the Data on Kubernetes community. Can you just tell us a little bit about your background and how you got into the position that you're in today?
Sure. Before I start, I want to congratulate you and the DoK community for the 100th session today. It's a big milestone for sure. And want to congratulate all the panelists, all the community members for openly contributing and also helping the community to grow. By the way, I am Sanjeev Ganjihal. I'm currently working at AWS and I've been with Kubernetes space for more than 5 years now. And a small fact about me, I'm the 100th person who got certified, CKA certified back in November 2017. And I've been helping a lot of enterprise organizations adopt Kubernetes, and it's not just Kubernetes, but again, cloud native technologies, working on infrastructure automation, DevOps, CI/CD, service mesh, containers. And in the current role, I'm helping AWS's customers pick the right AWS container services, and not just AWS container services, but also focus on open source technologies as well. So I've been helping customers grow their container adoption, and again, use the right technologies, use the right architecture patterns to implement Kubernetes at scale and deploy containers at scale. So that's a bit about myself and what I've been doing so far.
That's great. And now it seems that 100 is a very auspicious and special number, given the fact that you were the 100th person to get that certification. When you got that, you know, because that's the thing, it's not super common to have somebody in our live streams talking about 5 years of, you know, Kubernetes experience. The evolution that you've seen in those 5 years, and obviously, you know, in our community, once again, talking about running stateful workloads on Kubernetes. If you know, given the 5 years of activity that you've seen, what are some things that you might say that you've noticed over the course of that time about how things are changing, particularly when it comes to data management?
Absolutely. I think I've seen a tremendous shift, especially running persistent workloads or running databases or any workload that needs persistent on Kubernetes. I've seen a tremendous shift. And again, there's a lot of new players coming in the industry, focusing majorly on running data on Kubernetes. And there are a lot of solutions available now out there. But what I feel is, again, we are still early, even though we have reached a certain maturity level. But I still feel there are a lot of use cases where customers can benefit, and the solutions that we have in the market today can give more features for the customers and help them run their data workloads on Kubernetes. Again, it's all about confidence, because majorly enterprise customers, what they look for is, if I run data on Kubernetes, what about backup? What about restore? What about disaster recovery? So there are a lot of questions the customers always ask, and they always have this question. Kubernetes is a single tenant orchestrator, and what if the control plane is down? What if Kubernetes is down? What about my data? What about my workload? So they always have these questions, and we have started seeing a tremendous shift where we have started exploring application networking solutions like service meshes, talking about multi-cluster, talking about having some advanced data workloads, running big data applications, running artificial intelligence, machine learning applications on Kubernetes. So we are seeing a lot of growth in that area. But again, it'll take some more time for everything to settle in it. And again, we need some strong open source use cases that cover all the features. Right now, I would say 75% of the features are available today. If I talk about OpenEBS, if I talk about Portworx, Rook, Ceph, a lot of solutions are out there for persistent storage. But again, it needs some more maturity, is what I feel. But what we had 5 years before, where we were running just the stateless applications on Kubernetes, and whenever customers used to ask, hey, can I run stateful workloads? Yes, we have stateful sets running on Kubernetes, but is it perfect? Is it the best choice or best way to run? Yes, I mean, there are a lot of ifs and nos about running stateful set on Kubernetes, but today, with Portworx, with OpenEBS and other storage orchestration solutions, it has made the job of site reliability engineers or DevOps engineers or system administrators to confidently run stateful workloads on Kubernetes, because what they're doing is they're orchestrating the storage requirements and providing the platform, the storage layer, to applications running on Kubernetes. So definitely it has matured a lot. But as I said, some more growth is needed in this space.
Completely agree. It's nice to hear from you as well, to echo the same things that we found in our research report. We interviewed over 500 different organizations to see what their opinions were about that matter. And while, as you rightfully mentioned, that when we talk about, the core of this, when we talk about, OpenEBS, Portworx, Rook, Ceph, et cetera, the sort of foundation is in storage, but then we start branching out into other areas such as AI, machine learning, data streaming, other areas like that. So just for folks, if you haven't seen the research report that we launched in October, some of the very things that Sanjeev was just mentioning are in there. You can download it for free. It's on our website. So please take a look at that. There's a lot of interesting findings there that I think are going to be helping to show us the next steps that we'll be seeing in the coming months to the next couple of years. That being said, I don't want to take any more of your time, Sanjeev. So if you want to share your screen, jump right into your presentation. Folks, as usual in the audience, leave your questions in YouTube and we'll be happy to answer them live. If not, we can always continue the conversation in Slack. So Sanjeev, whenever you're ready.
Absolutely. Give me just a second.
Yep. Not a problem. Okay.
Looks like a small problem, but I think
that's okay. That's what makes us exciting in live stream number 100. I have to say, in 100 live streams, we've seen it all. We've had Amazon delivery folks. It's not just because you work in AWS. We've had Amazon delivery folks appear. We've had children. We've had dogs. We've had cats. We've had just about everything. We had talking about disaster, backup and restore. In a live stream that we did with a great SRE named Yuri from Google, big shout out to him, talking about kind of SLAs and SLOs and different kind of alerts that you have to set up. While we were talking about that, all of a sudden I was in Madrid at a friend's house and the internet crashed. So right as we were talking about alerts and when things go wrong, something very much went wrong, I switched to a hotspot on my phone and everything worked out fine. So anyway, we're very accustomed to being flexible, but let's jump right into Cape. Let's hear more about it.
Absolutely. Let me know if you can see my screen.
Yep, looks great.
Perfect. So I'm here today to talk about Cape. Again, I came across this solution. I felt this is definitely a game changer. Again, every tool out there in the cloud native space has some pros and cons. Every tool will not give you that 100% feature parity or all the capabilities, but what Cape has done today is tremendous. Again, it has taken whatever the open source solutions that we have available today and then enhance some of the features. But in a nutshell, I'll be talking about Cape today, covering some use cases, some features, and quickly do a demo where I will install Postgres and again, basically delete Postgres running on one of the clusters and quickly restore to whatever state it was. So I'll be working on that today. And the agenda is pretty straightforward, just covering what Cape is and covering some slides and then jumping directly onto the demo. It's a simple tool for all your multi-cluster application deployment and data management needs. And before I jump into Cape, again, just want to cover some challenges that we have today for persistent storage for containers. Again, I mean, not every customer is running their workloads, container workloads on the cloud, be it AWS, GCP, or Azure, or even Oracle or Alibaba. So there are different cloud providers available out there. So not everyone is running on cloud. They still have some on-premise presence where they're relying heavily on traditional storage solutions. But for the main challenges that I've personally seen, especially for persistent storage, is the traditional storage solutions are mapped to either a single host or a cluster. If you're running a SAN or a virtualized storage network within your on-premise environments, it's directly mapped to that host or a cluster. And it's not easy to assign the same storage to different workloads. Again, containerized workloads are ephemeral. They come and they go, and especially for workloads that needs persistent storage, you need that dynamic provisioning and allocation of storage. That is not possible with traditional storage. I mean, even though the traditional storage solutions, they have kind of adapted and enhanced their current solutions to support containers, but still it's not a direct mapping, or from a feature perspective, it's not as mature as what it should be. That's one of the challenges that I've seen. Again, these storage products, they lack container native data services. Again, they work for virtual machines. But again, when it comes to container workloads, they're not that great. And there's no workload mobility. Again, there's a lot of manual effort involved, especially when I'm running different workloads, and I have different storage requirements for each application. So with traditional storage solutions that I have, I don't get that workload mobility. And when I look at data reduction in availability mechanisms in the current traditional storage options, I don't have that. When I say data reduction, I'm talking about deduplication, compression, thin provisioning. A lot of solutions in the data reduction space, I don't have them available for containers natively, and all these storage solutions, traditional storage solutions that we have, they're not scalable for Kubernetes and they're not scalable for container workloads. So these are the common challenges where enterprises are struggling. And when we ask enterprises, hey, what are your common problems? Why don't you run stateful workloads on Kubernetes? And they say, we have so-and-so challenges running data-specific workloads on Kubernetes. And again, data management being a big problem, persistent storage being a big problem, disaster recovery, backup restores. These are some common problems where customers tell these are the barriers for limiting the container adoption as well. If you see, not all customers have migrated from monolithic to microservices and adopting containers. Big organizations are still relying on traditional VMs to run their applications, but not taking the benefits of agility, the release aspects of containers, and improving the developer productivity as well. So these are some of the reasons why customers always feel it's a challenge to run data workloads on Kubernetes or containers per se. And do we say it's a data problem in Kubernetes? No, it's containers. They're ephemeral. They come and go. And these traditional solutions, they're very slow and they're not suitable for current orchestration platforms. There is no application awareness today with the traditional solutions. And Kubernetes here is mainly solving application orchestration problem. But when it comes to a lot of data aspects where I want container granularity, especially with provisioning my persistent volumes, looking at the availability of storage, encryption, security, backup, restore, what about disaster recovery, and providing that centralized storage for my orchestration platform. I have solutions today, but again, there's these solutions still provide few features like backup restore, disaster recovery, and some of them provide storage monitoring and management, but there is no one tool that fills all the gaps today. And Kubernetes is mainly solving the orchestration problem, but not the data problem. And before I jump on, just want to talk about Cape. Again, Cape is basically I would just say it's a superhero. Again, I'm not sure why this is not yet popular. Again, it has community version and also the paid version. But again, community version, customers running small clusters can definitely benefit with Cape. It solves your application data management problems. And again, it supports multi-cluster natively, uses kubefed for federating multiple clusters. What it is doing is it is basically abstracting and automating your critical functionality, especially dealing with multi-cluster application deployments, data management across multiple clusters. So Cape, in a nutshell, is clusters across platforms and environments. So if you ask me, how should I abbreviate? It's just clusters across platforms and environments. And why Cape is popular, again, it supports a lot of Kubernetes platforms. If you're running on managed Kubernetes cloud provider, managed Kubernetes offerings, whether it is EKS, AKS, GKE, or running even Oracle Kubernetes, it supports OpenShift, it supports Rancher. Even if you want to run it on on-premise environments where you have your own data centers, you're running Kubernetes there, you can leverage Cape for application data management and even application deployment. And it supports a lot of storage backends, again, S3, Google Cloud Storage, you have Azure Disk, Azure Storage supports Minio, you have Restic, and it is backed by CSI. So everything is a CSI specification. And again, Cape is easier to install. You can pretty much use Helm charts. We have operators. We have customize. You can use customize to install Cape. And again, for application deployment, you can pretty much use native YAML manifests, Helm charts, customize, any operators that you have. Cape supports all those aspects as well. And I'll be talking about features in the next slide. But again, the major key differentiator, what I see is the rich UI. Again, it uses Project Valero in the backend. I'll talk about that in the next few slides. It is mainly helping developers with no experience in Kubernetes, no experience in backup restore. It's making the job of developers or even administrators to just go into the UI and click some buttons for backup restore, for application deployments, making it easier to just do everything from the UI. And it's very easy to use, and it is cloud and environment agnostic. You don't have to have a vendor locking or anything of that sort. So you can run Cape on any platform today. And some features I quickly wanted to talk about is disaster recovery. Again, if you're running stateful applications, you definitely want to look at backup and restore solutions. So Cape offers disaster recovery, offers data mobility and migration as well. If you have any requirements where you want to migrate from on-premise to cloud or cloud to on-premise, You can easily do that with Cape. And supports multi-cluster application deployment. Again, it uses kubefed in the backend for connecting multiple Kubernetes clusters, and you can deploy applications easily using Cape. And again, they're working on a CI/CD workflow manager. I think that is still in development, but that's something that is coming out soon. And again, Cape is managed by a Singapore-based company called BigMind. They've open source community version, and they also have a support version where you pay monthly for certain nodes, and you get all the features available out of the box. In some use cases, again, Kubernetes natively, we do not see any native backup restore options. Again, we have to rely on Project Valero for backup restore, for disaster recovery, for data movement between clusters. So we don't have anything that comes by native on your Kubernetes platforms. So Cape is basically facilitating your stateful application backup and restore. And again, with Cape, again, you'll see you don't have to worry about higher RTOs or RPOs. Again, you'll pretty much ensure your backups and restores are easier to take, and whenever there is failure, it's easier to basically restore from whatever the backup that you've taken. And it's a single platform. You can manage everything, your clusters, from a single place. And it's basically offering data protection, basically gives you scheduled backups option to take scheduled backups. You can have your retention schedules. You can do pre-post backup hooks. You can have custom actions. You can do a lot of things on the data protection side. From a data migration perspective, you can migrate from on-prem to cloud, from cloud to on-prem, and there's nice use cases Cape is solving for data migration. Again, for DR, disaster recovery, you always want to reduce the time that it takes to recover from infrastructure failures or data corruption or any outages. So Cape is definitely solving some of the problems there. And it is just extending the capabilities of Valero. Valero does not have a UI today, and a lot of limitations with Valero. But what Cape has done today is they have enhanced Valero's features, current features, and they've added a lot of new features to Valero. And now you can basically perform backups and restore from on-prem or cloud storage environments. You can backup either the application or the data, or you can do both. Like you can back up both the application and data. And again, you can set up on-demand schedule backups. Again, I can do that daily, weekly, whatever my requirements are. I can pretty much do that with Cape. And if I want to look at full backups or incremental backups, that is still possible with Cape. And good thing is I can restore the backup to the same cluster, or I have the option of restoring the backup to another cluster, whether it is again on-prem, edge, or running on cloud. So Cape is making it easier for disaster recovery, for protection, for migration, and some use cases. I mean, they talk about it on their website as cluster upgrades. Again, they've made not every customer wants to upgrade to latest version, but again, it is a best practice that you pick and upgrade to latest version. But again, some legacy customers always want, like, if it's running, why do I have to upgrade? So for such customers, for migration perspective, the Cape is also solving, like they can back up their current workloads and then upgrade their cluster versions and then directly restore the workloads on the new version, new cluster version. So Cape is definitely a beneficial solution is what I see here. And before I talk about why Cape, again, a lot of customers and a lot of users today use Project Valero for backup, restore, disaster recovery. But a lot of users have gotten and they told, hey, there's no UI for doing backup and restore. And Velero needs an empty namespace for restoring your workloads onto the same cluster or new cluster. And I cannot send backups to multiple locations today with Velero, because Velero is a single tenant installation, like it runs on every Kubernetes cluster, but I cannot send the same backups to multiple locations. And I can only do namespace mapping between the source and destination. But what if I want to migrate certain pieces? Like when I'm migrating, I want to map ingress changes. I want to change the storage classes, because if I'm migrating from cloud to on-prem, in my on-prem, I may be running an NFS-based storage, but cloud, it's a different storage, but I need that mapping. Velero currently supports namespace mapping, and it's designed for single tenancy. And right now, read, write, and read-only storage locations, unfortunately, with Velero, we cannot have those mixed options. It's the same case with Cape as well, but Cape is not solving all the Velero limitations, but some of them, Cape, they have enhanced Velero's features. And I'll quickly talk why Cape. Again, you can override workloads today. It's not possible with Velero, because it looks for the namespace, and you want that namespace to be empty. But with Cape, you can pretty much override whatever workloads are sitting in that namespace today. And it's easy install experience. When I do the Cape demo, I'll show how easy it is to install Cape. What I'll be doing today is I'll be using a couple of clusters running, again, using Docker Desktop and Minikube. But again, the same installation is applicable for if you're running on Azure, AWS, or Google. It's the same implementation using Helm charts. And it supports multi-cluster out of the box. So that's another key thing why I see Cape as kind of differentiator here, because it's handling the data movement aspects, data migration aspects, and disaster recovery aspects natively. And I can do that within the UI. And it has a nice UI. I mean, every UI, we all tend to find bugs. But again, the UI is definitely good, and there's definitely areas of improvements for in terms of UI as well. And good thing about Cape is I can map my ingress and storage class objects during migration. When I say ingress, it's not the same ingress URL for each cluster, right? I for one cluster, I may have a different ingress URL. For another cluster, I'll have a different one. I can do that. I can have my rules defined when I'm migrating from one cluster to the other cluster. So I can do that. And again, storage class, if I'm running on AWS, my storage class, I may be using EBS as my provisioner. But when I'm running it on-prem, my storage class will be different. So whenever I'm migrating, it gives you the nice capability of of changing these ingress and storage class objects during the migration. So this is something that I personally like. And again, it has community version. 10 nodes are free for life. So if you're running a 10 node cluster, doesn't matter what size, you can definitely use the community edition. But again, if you need more assistance and support, you can reach out to BigMind for help. And again, you can use Helm charts, you can use Docker Hub, you can use Ansible, GitHub, and there's an operator available today to install Cape. So definitely a nice open source project, and I think a lot of room to grow, and a lot of new features can be added to this platform to make the job easier for admins or SREs or even system admins in the organization to implement backup, restore, disaster recovery, and migrations easier. That's all I have in terms of covering the content about Cape and talking about the problems. What I want to do next is quickly move on to the demo, where I'll stop sharing the slides and quickly start with Cape installation, and then show you how the backup and restore will work.
Perfect.
All right. let me know if you can see my terminal.
Not yet, but I'm sure very soon.
All right.
One thing while we're waiting is on the subject of operators, since you mentioned that, it seems that a lot of the conversations that we have about running data on Kubernetes, operators kind of appear at one point or another. Once again, as someone who has 5 years experience, do you think as of right now, are there any other solutions apart from operators that can help make it easier for folks to run data on Kubernetes? Or do you think this is just going to be kind of the de facto standard for the next few years?
I think operators have made the life easier, but again, managing the operators itself, writing the operators itself is a challenging job because not everyone comes from that development background where they can write their own operators. And a lot of folks that I've interacted personally are coming from an infrastructure background and not very well versed with operators. Again, right now you can take your Helm charts, you can create operators from your Helm charts today. But again, if you want to truly create an operator and let the operator manage the underlying software for you, it's not that easy today. I mean, what we have seen last few years, we traditionally were relying on Kubernetes manifest, Helm charts, customize. But I feel even though the operators came into existence, I still feel it's tedious for SREs to build their own operators. And again, what if your operator has problems? Again, you still are revolving around the same circle. Instead, what I've been doing personally is just relying on Helm charts, just relying on customize, just relying on using these tools, which are very popular, which has a wider community, and getting help easily in any feature that comes that I personally want. I'm reaching out to the community and just creating a GitHub issue, and things are being worked out. So even though operators are making life easier, I still would prefer Helm charts or customize to deploy my applications. And again, I'm a big fan of GitOps. So again, when looking at GitOps, again, some operators I've seen problems running in the GitOps fashion. But again, if you're already using Helm charts, customize, or YAML manifest, and are already in the GitOps space, I think I would continue to do that, and I'm not worry about operators much.
Okay, very good. Yeah, we can definitely see your terminal now. So whenever you're ready, go for it.
Just want to make sure it's visible for everyone.
If you want to zoom in a little bit, if you can, that's always helpful. But from what I saw earlier, it's okay.
Okay, let me see if I can.
Yeah, but a little bit of zoom always helps.
Is it good?
Yep.
Perfect. So I'll start with Cape install. Right now, what I'm going to do is, this is my Mac. Again, Mac is very powerful. I like my Mac a lot. So I'm going to use Docker Desktop. I know there's Docker rate limiting issues, but again, I'm not going to pull a lot of images, so should be fine. So first thing, what I want to do is I want to copy the IP address. I want to get the IP address. I'm just going to run this command. This will basically get me the IP address of the machine. And next, what I'm going to do is I'm going to install Nginx. Again, I need an ingress controller to expose my Cape UI. So I'm just going to install Nginx ingress controller, and I'm going to run my alias. And I'm just gonna say kget-ns, which is kubectl get namespaces. And if I say kget pods in the namespace ingress nginx, I should see my ingress controller up and running. The next thing that I want to do right now is go ahead and install Cape. For that, I already have a Helm chart that I basically downloaded. So I have my chart YAML, templates. If I go to my templates, I have some custom resources and my deployment file, and I have my values file where I have passed in some values. I need to go back, and I'm passing some values, but I'll be overriding some of these values when I run my helm install command. I'm just gonna go ahead and do the helm install. I need to go back. It did not find the cape chart. Now it did. It says cape is deployed. I'm just gonna clear and do a helm ls, and I should see cape is installed and the status says deployed. And if I just go back and do get namespaces again, I should see a cape namespace coming up. And if I do get pods -n cape, I should see all pods up and running. There should be an ingress that should be created with the Helm chart installed. So I'm just gonna say kget ingress -n cape. So my cape UI can be accessed on 192.168.1.65.nib.io. So what I'm gonna do is I'm gonna bring a browser here and try to access the application, the cape UI. There you go. So I have my cape UI. What I'm gonna do, the first step is basically select the organization. This is an important step. Whenever you want to use the cape UI, you will specify the organization. So I'm just gonna say add new organization. And the first step that I want to do is give a name to that. I'm just gonna say Sanjeev org and just say click complete. By default, it'll show what organization it is, which is Sanjeev org that I just created. Select that and you should see the cape UI coming up. The first step what we need to do is, before we do the backup and recovery, we need to add clusters. So I'm just going to add a single cluster and you have different options here. You can choose cloud provider, managed Kubernetes, EKS, AKS, DigitalOcean, Google Kubernetes Engine. You have Red Hat, OpenShift. If you're using OpenShift, you can do cape on OpenShift as well. But for this demo, I'm just going to click private Kubernetes cluster, and I have different options here. I can upload my kubeconfig or I can connect cluster using kubectl. So what I'm going to do is I'm going to use kubectl. I'm just going to give this private cluster, or yeah, let's keep private cluster 1. I'm just going to say region is on-prem because this is running on my Mac. I'll just say connect cluster using kubectl, and when I click connect, there should be a command that you should see on the screen. You should just copy this, go back to your terminal, and you can pretty much run this, and it'll basically install few components, few cape components. It'll configure the namespace again. It'll add some cluster role binding, service accounts, a deployment and service. So if you just do get pods -n cape, I should see an agent that is basically running here, which just got started 14 seconds ago. So if I go back and open my cape UI, it should say successfully connected the cluster, and you can close the tab and you should see, let me resize this browser, or let me reduce the size of it so that this looks good here. So if you see, I've added a cluster here which says private cluster 1. Provider is other because this is a private cluster and I've chose on-prem, and it'll tell you the number of nodes that you have. I just have a single node cluster. Backups, no backup. The status of the cluster is healthy. What I want to do next is basically for me to work on backups and disaster recovery. I need to install some components there. But before that, I quickly want to cover federation. So if you want to create federation, again, this is purely based on KubeFed project. You can do app deployments by federating these clusters. You can create the federation using this option. And again, you also have the option of managing components for backup and restore, for application management. So you'll have to come here and this is how you'll see what clusters you have. Right now it says current cluster as private cluster 1, but assume you have additional clusters. You'll select from the drop down here, and you're going to install the backup and restore operator. I'm not going to show this from here. What I'm going to do is go to clusters, and then under component section there is a button called install, and there's some other options here. You can edit the cluster, you can schedule backup, you can manage components, reconnect, disconnect. So there's some options that you can see in the UI from the Cape UI basically. Click on install, and this will directly take you to the manage component section, and again showing the private cluster 1, which is a cluster that I just added to the Cape UI, and I'm just going to click on install. And here it'll ask you different options. Select backup location. You use existing backup. We don't have anything, so I'm just going to click on add new backup location. You can choose different cloud options here: Ali Cloud, AWS, Azure, GCP, or Hawaii basically. But what I'm going to do for this demo purposes is use Minio. Minio is again an in-cluster solution wherein you can have a persistent storage solution, or where you can store your data. So I'm just going to choose Minio here. And the backup location name, I'm just gonna give backup 1. Bucket name, again I'm just gonna give backup 1. Bucket prefix, you don't need that. Access, I'm just gonna call my cluster name. And secret key, again you can give any secret key value here. I'm just gonna keep something private here. Yeah, do remember what you're using. Again, your backup location is backup 1, bucket name is backup 1, access key, I just named the cluster name as access key, and secret key is whatever your choice. So I'm just going to click on next. Here Restic is again it's a nice cloud agnostic where you don't have snapshot features in your on-premise environments. You want to install you want to take snapshots where you don't have that native availability. You can enable Restic, and that will basically take snapshots of your persistent volume. So again, location of your host path right now, it's warlib kubelet pods, and if you want privileged, again this is for OpenShift, but again just enabling Restic should be good for this demo. And it'll give you all the information for review. Backup location is going to be Minio, which is running on the cluster itself. Backup name, bucket name, access key, secret key, and Restic enabled, true or false, and then gives you the host path. And I'm just going to click on install. It's just going to check for some role-based access control permissions. It'll install the Cape Valero operator, and after that it'll do the Minio install. And once that is done, we are good to get started on backup and recovery. Just waiting for this to complete. And again, in the backend, as we talked during our presentation, Cape is basically using Valero in the backend, but again, helping with backup and restore from a UI perspective. You can use Cape UI to perform backup and restore, and even work on disaster recovery scenarios and some advanced use cases with Cape. So we'll just wait for Valero to install. And once this is done, we can quickly take a look at a sample application that we can deploy. What I'll do is I'll deploy Postgres. I'm gonna use Bitnami Helm chart. Again, you can easily get this from the Helm repository. Right now it says Cape backup and restore operator is installed on the cluster. If you want to go back and look at the cluster, So you should see Valero, which is installed. So I'm just gonna say get pods. So Valero is up and running. So Minio is part of it. Restic is for snapshots, and my Valero pod is up and running. And if I just do get pods -nk, I should see a controller, which is a backup and restore controller, which just got installed 2 minutes 3 seconds ago. So there will be some controllers that will be installed by Cape on the cluster to perform backup and restore. Now that all the components are up and running, I'll just go ahead and quickly show the cluster here again. If you see backup and restore is kind of installed, I don't see an install button here. I can go back to backups and disaster recovery. Right now, if you see the backup location, there is one backup location, which is Minio. And if you see read-write access, it's pretty much with cluster 1, private cluster 1. So what I'm gonna do is, before I click on backup, I'm gonna install a few things on the cluster, which is Postgres. For that, first what I'm gonna do is I'm gonna just add a Helm repo, which is I'm gonna be using Bitnami, so it says it already exists, which is good. So what I'm gonna quickly do is install Postgres, and it's just a simple Helm install command, and I'm gonna use the Bitnami PostgreSQL Helm chart, and I'm just setting the PostgreSQL password as password. All right, it says deployed. And what I'm gonna do next is I need to export my Postgres password. What I'm gonna run is I'm just gonna run this command. I'm just gonna copy this. Two steps here, pretty straightforward. So I'm just gonna run the export Postgres. If I do echo $Postgres_password, that's the password that I passed in using the set command in the Helm install. And next I'm just gonna run a client. This should basically open a PostgreSQL client. It should open a prompt. Give it a minute. I'm just gonna press enter. That's where I'm inside the PostgreSQL client. What I'm gonna do is I'm gonna create a simple database called example. And if I should see an example database created there. What I'm gonna do right now is create a table. Give me just a second. Yeah, just created the database. Give me just a second. Computer is kind of slow. I'm just gonna create a table here. So if I just do select star from users, I should see a couple of users that I have created here. What I'm gonna do right now is basically exit from this client, or I'm just gonna open a new terminal here and run this alias command again. And if you see, I have my PostgreSQL client running and my Postgres, and if you see my PVC, I have a Postgres persistent volume that I created with capacity 8 gig. Again, this is by default when I install the Helm chart. And if you see, the storage class is hostpath. So if I do get storage class, it's hostpath by default because I'm using Docker desktop on my Mac, and the provisioner is Docker IO hostpath. And this is about the persistent volume that got created, and I'm just gonna do get PV, and if you see, the status is bound, reclaim policy is delete. So what I'm gonna do is I just created the database called example and created a table called users, and I've inserted some values into the table, John and Jane. Now what I'm gonna do is go back to KPUI and quickly take a backup. So backups and disaster recovery come under backup. You can click on create backup. You should see from cluster. I'm just gonna name this BKP1 and select. I'm gonna just say specific namespaces, so you have the option of choosing all namespaces or specific. Here I have a lot of namespaces, so I'm just gonna select the default, because that's where my Postgres is running. And if you see, I'm gonna you have the option of select backup storage type, so you can either include persistent volumes in backup or exclude persistent volumes in backup. So I'm just gonna say include persistent volumes because I need this. And if you see, there's a PV, a persistent volume that is showing up, which is the PV for PostgreSQL. And I'm gonna just click on next, and you have the option of one-time backup, or you can have a recurring. Again, this is a nice option that I like, and again, you can do it on a schedule. You can use a manual cron expression, and you can select the option year, month, week, day, hour, minute. So this is a nice feature. What I'm gonna do right now is just use one time for now, and I'm just gonna click create. And if you see in the UI, it says the backup is in progress, and once it is completed, you should see that the backup is now complete. And if you go back to backup locations, this is where we are storing everything on Minio, and I just created a backup, and now I need to restore. But before I restore, I need to make sure I clean up or delete my Postgres running on the cluster. So I'm just gonna come back here and just say kget PO. I am just gonna go ahead and delete my PostgreSQL. It's a stateful set running, so I'm just gonna say kdelete STS, which is stateful set. I'm just gonna pass this, and if I just do get pods, you should see my Postgres terminating. Let's run a watch. It's just gonna take a minute or two. Just waiting for it to terminate. Yeah, so I don't have a stateful set up and running right now. There's just a client running. I'm just gonna go ahead and delete the client too, because when I do the restore, anyhow, I'm gonna connect to the client again. So I'm just gonna delete the client. For this demo, what we're doing is we're not doing the backup restore on another cluster, but again, just the focus was to showcase how Cape works and how to perform backup and restore. But again, you can add another cluster to the Cape UI and you can perform backup and restore easily. And I've shared some instructions in the PowerPoint, and there's some nice tutorials created by BigMind to perform cross-cluster backup and restore as well. So the client is gone, so I don't have anything in my default namespace. What I'm gonna do is go back to my Cape UI, and I'm gonna say restore, or you don't have to come to restore again. You can do from here itself. You can do a restore. You can, again, it'll take you to the restore section. All right, I'm just gonna some UI issue with some UI, so I'm just gonna do a restore, and I'm just gonna say the name of the restore is restore 1. It's a one-time backup, and it should show backup 1. This is where we have taken the backup, and I'm just gonna click next and select namespace. It's gonna be default because that's the namespace that we packed up. And I'm just going to leave all resources, and this is where it gets very interesting. Resource mapping rules. So you can create new or select from previous rules. For example, you can right now today you can do ingress class and storage class. Again, you can select namespaces, your cluster name, for example, your fully qualified domain name from current cluster to target cluster. You can do that, and you can apply to all objects or a specific object. So it's a nice thing, which is very good when you're especially restoring on your target cluster. But for now, I'm just gonna skip this and moving on to volumes. I just want to restore my volume, so I'm just going to restore everything from this backup, and I'm just going to click on restore, and you should just say I agree. Again, after you do that, it just takes a few seconds for your restore to complete. Again, it is using the backup that we created here, and we just restored it back to the cluster. So it says completed. So if I go back to my terminal and say get pods, yeah, my Postgres is up and running. If I do select star from users, again, I should see my John and Jane users still listed in the Postgres database. So I'm just gonna go ahead and clean up the pod, the client. I'm gonna recreate the Postgres client by just running the command here. I'm just running this Postgres kubectl run command here. Okay, I didn't supply the password, so let's go ahead and supply the password. For that, I'm just gonna export this password here and redo the kubectl. And now if I do select star from users, I should see my data coming back, which is John and Jane. With this example, what we did is we installed Postgres on the cluster, and we used Helm chart, Bitnami Helm chart to install Postgres, and we used Cape to basically perform backup for the persistent volume, especially for the Postgres SQL. And then we came here, deleted the client and Postgres running on the cluster just to simulate a failure. And then we went back to the Cape UI and did the restore from there. And now I am able to do select star from users. I'm able to see the same data. So this showcases nice backup and restore features using Cape UI. And again, there's some additional use cases with Cape UI. You can do application deployments and application management across clusters, and even backup and restore across clusters. But again, thanks a lot for joining today's presentation, and I hope you liked Cape UI demo. And please feel free to reach out to the community if you have any questions. Thanks.
So Sanjeev, I hope that you can see I'm going to share my screen really quickly, because as tradition obliges us, if we've done 100 live streams, I don't know how many pieces of art and rap and music and different things like that we've done, but it's been quite a few. And it's one of the things that really gives us a unique identity as a community. So I'm going to share my screen really quickly, because while you were talking, we had our wonderful graphic recorder, Angel, who's always with us in the shadows, lurking in the background. So he created this drawing of the different things that you were talking about the different kinds of problems and then solutions, starting from the very beginning of what you were mentioning about, persistent volumes, all the things that give us a sort of backbone of running data on Kubernetes, then moving on further into the specific elements that are provided by Cape. So I think it's a nice drawing, and we'll be definitely sharing that with you. And like I said, thank you very much for your time today. And we'll definitely be sharing the rest of the demo once that gets up and running. And thank you to everyone in our audience for asking great questions. And we can definitely continue the conversation on Slack. So take care and have a good one.
All right. Thank you.
Bye-bye. Cheers.